Okay, so here's our last part of factoring that we're going to talk about, basic part of factoring that you need to know. Remember that factoring is just undistributing or unmultiplying. So if we're talking about special multiplication review, these, and you need to know this word, this is an example of multiplying conjugates. Remember that a conjugate, I feel like I've told you this word, but if I haven't, a conjugate is when these two factors look exactly the same except that they're opposite signs. Notice one is addition and one is multiplication. All right, so I'm actually going to show you just kind of the quick way to multiply. Remember, this is first we check like the first and the last, right? Well, no, I'll just distribute like we normally do. Okay, this is 4x squared plus 6x. And then when I do this bottom part, I'm going to get minus 6x minus 9. Okay, so what I want to show you is that this middle is going to, that's where you usually combine like terms, and it's going to end up canceling itself out. One thing that you should always note is that conjugates always are going to cancel. That's what makes them conjugates, is that they are opposites, and when you multiply, they will cancel. So the final answer I'm going to get here is 4x squared minus 9. Okay, so I want to show you a pattern so that you can kind of see where that's coming from, because these problems should be shortcut problems. And the pattern that I want to show you is this. Think about this 2x, and we're thinking about going backwards, right? We're talking about factoring, so we're thinking about if we worked this problem backwards. We have 4x squared here, and that becomes 2x and 2x. That's because 2x times 2x equals 4x squared. We also have minus 9, which is coming from negative 3 and positive 3. So there's a few things to note about these. And these are things you absolutely have to know, so make sure you write these down. This special factoring pattern is called difference of squares. And that's because, one, these are always subtraction. And the reason that they're always subtraction, if you think about it, if they're conjugates, remember one has to be positive and one has to be negative. And that's the only way to multiply and get a negative number is to do a positive times the negative. So you have to have subtraction. And the other requirement is that you have to have perfect square numbers. If it were me, on the margin of your paper, and I'll even scroll over to list them, you need to list your perfect square numbers so that you know them. You should have these memorized probably all the way up to 15. So 1, 4, 9, 16, 25, right? This is 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5. All right, so I'm just writing these down. You need to have these memorized if you don't already. Most of you stop at 144 just because you've only gone through 12s, but you need to know probably higher than that. So 13 squared is 169, 14 squared is 196, so I remember those because they're kind of backwards from one another. And then 15 squared is 225. So you need to know this list of numbers, all right? So now I'm just going to show you how we factor these. And this should be pretty straightforward. It's literally just the same pattern over and over again. So this top row, I'm going to zoom in over here. This top row is very simple. All of these have subtraction, and all of these have perfect square numbers, right? 64, 81, 16, 1, 9, 25, which means all of these are going to be perfect squares, or they're going to factor to give you conjugates. All right, so I'm going to break 9x apart. When I break this apart, that gives me 3x and 3x. And then I'm going to break negative 25 apart. That's going to give me positive 5 and negative 5. And that's it. All right, same thing on the next one. Break my 16x squared apart. That will give me 4x and 4x. Negative 1, sometimes this gets people stuck, but what do you multiply to get negative 1? You should multiply positive 1 and negative 1. It does not matter which one you put first as far as the positive or negative. All right, same thing on this last one. I'm going to break 64 apart. That's going to give me 8x and 8x. And then I'll break the 81 apart, negative 81, so that's going to be plus 9 minus 9. Now, obviously, because this is math and that's how life works, some of these are a little bit trickier. So let me show you some problems that kind of give you some tricks to them. This question, you might look at this and say, okay, well, this is subtraction, which is good, but it's not perfect squares, which is true. But remember, the first step to factoring is always to check for a GCF. So in this case, I see that there is something I can take out of 8 and 50. I can take a 2. When I take that GCF out, now I'm back down to something that is difference of squares. So the GCF falls down, and then I just do my GCF, or difference of squares pattern again. 2x and 2x, plus 5 and minus 5. Okay, same thing is going to happen on this next one. Now, I'm going to show you this next one as if you didn't realize that. So this next one you might say, oh, that's just a normal problem. 116, those are both perfect squares. So let's say that you do that, and you do 10x minus 4, 10x plus 4. Now the problem is, when you factor, this that's left on the inside should not have anything left in common. But right now, there's a GCF still existing here, right? You can take a 2 out of this. You can also take a 2 out of this one. Okay, so if I take a 2 out of each of those, that's going to bump them down to be 5x minus 2 and 5x plus 2. I know that part's better. But think about, if you took a 2 out of both of them, that really means that you took a 4 out altogether. Okay? And you could have seen that in the very beginning, that both of these divide by 4. And that would have given you 25x squared minus 4, which would have still led you to this final answer. But I wanted to show you how to check in case you forget to take the GCF out. So you may want to make a note to yourself that this is if you forget GCF. And I know I wrote forgot, whatever. Okay. Last question. You will see ones like this on the EOC at times. This right here, you might be tempted to say, well, this could be broken up and be x. Sorry, my app went weird. All right. You might be tempted to say, well, this is x plus 3 and x plus 3. Like, you're like, oh, that's not a negative sign, so I'll just make them the same. Okay, the problem is these are not conjugates. And so when you try to multiply this back out, sorry, my thing is delaying. If you try to multiply this back out, you're going to get x squared, I'm going to skip some, well, no, I won't skip, plus 3x plus 9. You get, this middle part doesn't cancel, so you get x squared plus 6x plus 9, which is not what you had in the beginning, so this is wrong. This right here does not factor. Because this is addition, it does not factor. All right, you need to make sure that you have this written down in your notes, and we will do some kind of more challenging problems, more challenging applications of this together tomorrow in class.